Hello everyone, welcome back. In this video, we are going to continue our conversation about AND behavior. In the previous video, we talked about how do we use a graph to analyze the two sides of the ending part of the graph, and we use a symbol to figure out the AND behavior of the graph. Today, we are going to explore more property of AND behavior. We are going to check is there any connection between the AND behavior with the degree and the leading coefficient of polynomial. So the first, we are going to check the 6 graphs here. Each graph, the expression of the graph, the expression of the function, and also the graph is provided. What we are going to do is we are going to answer the question regarding leading coefficient, degree, and also we are going to analyze the AND behavior. I'm going to use the first 2 examples to finish this, and later you can definitely pause the video to finish the rest part on your own, and later to save our time, we can just jump to the final conclusion to see is there any pattern or properties for us to discover. So let's check the first one. The first one, as you can see, is already in standard form, and leading coefficient is a number in front of the term with highest degree, which is 2, and the number is positive, and the degree is here is 3, so the number is odd. So the AND behavior, as you can see on the right side, x is approaching to the positivity, and y is approaching to the positive infinity. And when x is put to the negative infinity and y is going down, so that's y is approaching to the negative infinity. Let's check the second one. Second one, same thing. Leading coefficient is 3, which is positive, and degree is 5, which is also odd. And as you can see, the similar behavior here. So which is as x approaching to the positive infinity, y is approaching to the positive infinity, but as x is decreasing, then y is decreasing too. Okay, so you can definitely pause the video here to continue to finish the rest part and then compare the answer with me. Now to save our time, I'm going to just show the final answer as an indicator to see what's the result here. So this is the final complete answer regarding each behavior. So now we are going to take some time and to observe what pattern do you notice. So you can definitely pause the video to think about this question, or you can just go along with our conversation to finish this thinking process. So as you can see, when we deal with odd degree, the graph is always upside down, right? But the only difference is sometimes it's going like this, like x increasing, y is increasing, like x and y going to the same pacing. But sometimes it's reverse. X is getting smaller, but y is increasing. That's for the odd part. But for the even part, as you can see, 4, 4, 6. For the even part, the graph is actually always go the same direction. So the ending behavior is always same. Either goes up or goes down at the same time. But which is indicator to decide when it's going up, when it's going down? Some students probably already noticed the leading coefficient. When we have positive one, it goes up, but when we have negative one, it goes down. So now we are going to summarize every single finding here in a simple chart to determine what is our final finding. Let's check this one. Okay, so in this little chart here, I'm going to use 2 things to check this. So one is degree, and one is leading coefficient. To save the space, I just use LC to represent leading coefficient. So the degree, we have even part, we also have odd part. So we have even degree, we have odd degree. But for the leading coefficient, we have positive, we have negative, right? So only this, 2 cases, but we combine together is actually 4 scenarios. So when we have even degree and the leading coefficient is positive, the graph, the ending behavior is going to be like this. So the ending part is both going up. So we can describe the end behavior as x approaching to the positive infinity, y is approaching to the negative infinity, and x approaching to the negative infinity, is actually going up, right? Y is going to the positive infinity. So for the x part, it goes the same pace, right? Now let's check the leading coefficient as negative. As we notice that for even degree, they still goes up to the same direction, but when leading coefficient is negative, it will go like this. The ending part is going to decreasing at the same time. So that's why we are going to analyze the end behavior as x approaching to the positive infinity, y is approaching to the negative infinity. As x approaching to the negative infinity, y is still approaching to the negative infinity. But for the odd degree, let's check. When leading coefficient is positive, then the graph goes to the same pace as x, meaning when x is increasing on the right side, y is increasing. But when the left side is going to go like that. Whatever in between, we don't know that. It's not something we're going to focus because we focus on the end behavior. So how do we summarize this end behavior, which is as x approach to the positive infinity, y is approach to the positive infinity. As x approaching to the negative infinity, y is approaching to the negative infinity. So for the leading coefficient is negative, so everything is reversed. This time, when x is getting smaller, which is on the left side, y is actually increasing. Whatever in between, we don't know, but for the ending, the other side, when x is approaching to the positive infinity, y is actually decreasing. So how do we summarize this? It's going to be x approaching the positive infinity, y is approaching to the negative infinity, but as x approaching to the negative infinity, y is approaching to the positive infinity. Okay, this is how we summarize, this is how we use the leading coefficient and degree to summarize the end behavior of the graph. So as you can see, with this knowledge, with this information, we don't even need to check the graph. We can use the expression of the polynomial to figure out what is end behavior of the function. Okay, thank you so much for watching this video, and I hope this video is helpful. See you soon, everyone.